Okay, so solve x when 2 cos x plus 1 equals 0. So when we're solving an equation, a trig equation, we want it to equal something. So first I'm going to move that 1 over. So on the other side it'll become -1. And the next I'm going to move is this 2 over. And because it's timesing on this side, it divides on the other. So I've now got the question of when does cos x equal -1/2. So when we do these questions, we always just originally think about the first quadrant, and we've got to think about what angle will give, so what angle will give cos to be 1/2, okay? So if we think about that and we use our hand trick, say this was our hand, okay, now remember cos is the square root of the left, so if I had this one, square root of 1 over 2, that will give me 1/2, so square root of 1 over 2 will give 1/2, so that means I would have put this finger down, and that finger is our, either we can say pi on 3 or the 60-degree finger. Because we're talking about radians up here in our domain, we will keep it as pi on 3. Okay, so we know that cos pi on 3 equals 1/2, but we actually want it, when does it equal -1/2? Now cos is negative out here, so this is pi, and we now know it's when it's pi on 3, so I could say when we minus pi on 3, so that would be 2 pi on 3, or cos is also negative out this way, so when we add pi on 3, so we could say 4 pi on 3. So I find out when does cos x equal 1/2, -1/2, when x is either 2 pi on 3 or 4 pi on 3. Okay, now, but they want us to go between -pi and 4 pi. So we have to probably find other answers. And we find other answers by adding or subtracting the period to the current answer, the first two answers. Okay, so I need to get the period of this graph, and the period of this graph is actually, so it's always 2 pi divided by n, so it's 2 pi because it's 1, n is 1 in this case. Alright, so we're going to add 2 pi. Now, because we've got talking in thirds, I'll add thirds in terms of, I'll add 2 pi in terms of thirds, which would be 6 pi on 3. So I can add 6 pi on 3 to this answer, so that would give me 8 pi on 3, and if I add 6 pi to that answer, it gets 10 pi on 3. Now they want me to keep going up to 4 pi, which if I was talking about thirds would be 12 pi on 3. Okay, so I can't go any further. That's as far as I need to go. Now I can also minus the period. So remember I said you could minus, so I can also minus from these answers 6 pi on 3. So if I do that, so 2 pi on 3 minus 6 pi on 3, that will be -4 pi on 3. And if I did 4 pi on 3 minus 6, I get -2 pi on 3. Okay, now we have to go back to -pi, which if we're talking about thirds would be -3 pi on 3. So I only really, this 4 is out of it. So these ones become my answer. And I probably could solve the equation, and I might just write, so if I summarize out, when does cos x equal -1/2, when we have this domain, I'm going to say when x equals, and I'll put them in order from smallest to highest, so -2 pi on 3, 2 pi on 3, 4 pi on 3, 8 pi on 3, and 10 pi on 3. Okay, so that would be the final answer. Okay, so once again, we want to rearrange this one. So I'm going to move this 2 over, and it's going to become divide. So the first we think about when we're solving these, we still just find what if it was just cos x equals root 3 on 2, we find just what that would be first. Okay, so if we're thinking of our hand trick, okay, we want to do cos, which would be the square root of the right way. So we want these 3 fingers to be the square root of 3 over 2. So that meant this finger went down, and that was and I'm going to talk in radians, that was pi on 6 or 30 degrees. Okay, so we know that cos equals root 3 on 2 when it's pi on 6. So we have, when this is pi on 6, we get that. And cos is also positive down here. So if you go one lap, it's 2 pi, or we could write 2 pi as, what are we going to say, 12 pi on 6. And because we're a little bit short of that, it's actually 11 pi on 6. So we can say cos x equals root 3 on 2 when x is pi on 6 or 11 pi on 6. Okay, so we do that over here. Back in our, we're going to say we'll just write when 2x equals either pi on 6 or 11 pi on 6. Okay, but we've got this 2 here and we have to move it. So we move it across, and it times down the bottom of, or divides, those answers. So times by 2, times by 2. So we end up with our 2 answers is pi on 12 or 11 pi on 12. Okay, now if we think about this, or the question and the domain, because I'm talking about 12ths, I'll just change that. That would be 12 pi on 12, and 2 would be 24 pi on 12. Okay, so I probably don't have all the answers. So once again, I'm going to add and subtract a period. Okay, so let's find out what the period of this graph would be. The period would equal 2 pi divided by n, which is that number, 2. So it ends up being pi. Okay, so if I change that pi to be in 12ths, because we're dealing in 12ths, it'll be 12 pi on 12. So I'm going to add, or I'm adding a period. So I'm adding 12 pi on 12 to those 2 answers. And that would give me, so pi, that would give me 13 pi on 12, or it would give me 23 pi on 12. Now, I only have to go up to 24, so I'm pretty sure I can stop there. And now I might minus the periods to get the other answers. So they would be the earlier answers, so minus. So if I do 11 pi minus 12, I get minus pi on 12. So that was that one. And if I minus this one, pi on 12 minus 12, I get minus 11 pi on 12. Okay, so, and that fits in with my lowest value. So my answer, so my final answer, when does cos 2x equal root 3 on 2, when x equals, and I'll write all of them out, 11 pi on 12, pi on 12, 11 pi on 12, sorry, oh, it's getting very repetitive, sorry, 11 pi sorry, that was minus, no wonder I'm going cuckoo here. Alright, and pi on 12, 11 pi on 12. I'm just writing them out again. 13 pi on 12 and 23 pi on 12. So I'm just putting a final answer, writing it out like that. Okay, so with this one, we're going to rearrange it. So I'm going to move this one over. So I'd have negative 2 sine 2x equals negative 1. And then I would move this negative 2, which is timesing, and over. So it will divide. So I end up with sine 2x equals negative 1 over negative 2. So I get sine 2x equals a half. Alright, so remember we're just trying to find, first of all, when does sine x equal a half? So if we think about our hand, sine is the square root of the left fingers over 2. So I really want the square root of 1 over 2 because that'll give a half. So that means I've put this finger down, which is the pi on 6 or 30-degree one. So we know, alright, so we know that sine equals a half when it's pi on 6, and sine's also positive up here. So if that's pi, that would be 6 pi on 6. So up here, if we take pi on 6 away, it'll be 5 pi on 6. So my two answers is when x equals pi on 6 or 5 pi on 6. Okay, so we bring that down here and we say when 2x equals pi on 6 and 5 pi on 6, but we're going to move this 2 and it's going to get multiplied down there. So it'll be x equals pi on 12 and 5 pi on 12. Okay. Go back to where they want our domain. So they actually want us from negative 12 pi on 12. I'm just changing it to 12 so I can see. And again, back up to 24 on 12. Alright, so I need to add and subtract the period. Alright, so to these two answers. So let's find the period first. So the period is always 2 pi divided by n. So 2 pi, n in this case is 2. So pi, which I'll change to 12ths. So it's easier. So I'm going to add 12 pi on 12 to these two answers. And that will give me 13 pi on 12 and 17 pi on 12. Okay, and then I'm going to minus this time, and minus, we can also minus. So 5 pi on 12 minus 12 will be negative 7 pi on 12. And then pi on 12 minus 12 pi on 12 is negative 11 pi on 12. Okay, so there is, now I'm not going to get any more. So these are my solutions now. So just rub that out. That was just us adding and subtracting. So if you just write in summary, so the question was, when does sine 2x equal a half when we're saying x is an element between negative pi and 2 pi? We're saying our answer is when x equals, and we'll write them all out. So they normally write them lowest to highest, which is why, yeah, I'm writing them out like that now. Okay, over 12 and 17 pi on 12. Okay, so that would be your answer there. Okay, for the equation cos equals 2x equals 1, the number of solutions in the interval between 0 and 2, 5 is. the sum of the solutions. So we pretty much want to know when does cos, if we do it like we normally do, when does cos x equal 1? And if you think of our unit circle, cos x equals 1 when the angle is 0, because up here would be 0. So we also know 0 or 2 pi. So we could say here when x equals 0 or 2 pi. Okay, but the question actually is, so when does cos 2x equal 1? So we could say when 2x equals 0 or 2 pi. Okay, but we have to divide them by 2 because of this 2. So we get 0 divided by 2 and 2 pi divided by 2. So we end up with x still 0, but we get pi. Now we need to go between 0 and 2 pi. So we probably want to add a period to our answer like we normally do. And if you look up here, the period for this graph is 2 pi divided by 2, so it's pi. So you can add the period. So we're going to add pi to them. So 0 add pi just gives this answer again, but pi add pi will be 2 pi. So we've actually got 3 answers here. And the question said, what is the sum of them? So the sum, meaning 0 plus pi plus 2 pi. So therefore that is 3 pi. And that's how we get that answer. Okay, so with this one, we're just going to we're finding when cos is 3x over 2 equals a half. So just like we normally do, just think about when does cos equal a half. So if we think about our unit circle, so we're going to find out our first answer. So if I think of my hand, and we would have square root 1, because the cos, we want it to be a half over 2. So that means we've put down this finger. So that finger is the pi on 3, or the 60 degrees. So we're going to say when it's pi on 3. Now, cos is also positive down here, so that'd be 2 pi, which would be 6 pi on 3. So it's also on 5 pi on 3. So when x equals pi on 3, or 5 pi on 3. So you come back to this original one and we'll write like we do. So we'll say, well, cos 3x over 2 equals a half, and we'll just write when 3x over 2 equals, and we can write our 2 answers that we got there. So we said pi on 3 and 5 pi on 3. Okay, so what we're going to do is essentially we're timesing this x by 3 over 2. So we bring it over and we're going to divide by 3 over 2. So divide by 3 over 2. When you divide by a fraction, you times by the flip. So I'm flipping it over there. So that'll be one answer. And then you've got 5 pi over 3, and I'm going to times it by 2 over 3. And this will be my second answer. So there's me dealing with that 3 over 2 part. Okay, so I end up with my 2 answers. They're actually going to be 2 pi over 9 and 10 pi over 9. Okay, so I've got that. Now we've got to go back to and think about where they want me to do all my answers from. And they're talking about halves. So I'm going to make it a number that both 9 and 2 go into, which is 18. So I'm going to say negative 9 pi over 18. That's the equivalent. And this one's like saying 9 pi over 18. And I'll change these guys to 18ths as well. So it's going to be when x equals 4 pi on 18 or 20 pi on 18. I'm doing that so that when I add a period, add or subtract a period, it's in the same thing. So let's think about what is the period of this graph. So the period equals 2 pi divided by n, which is the number in front of the angle, which is 3 over 2. So it's 2 pi times 2 over 3, so it equals 4 pi on 3. Alright, so we are going to add 4 pi on 3 to all of these, to these two answers. So because I'm talking in 18ths, I might change this to 18ths. So I'd have to times that by 6, and I'd have to times that by 6. So I end up with, I'm going to add 24 pi over 18 to all of these answers. So add 24 pi on 18, add 24 pi on 18. So that would take me up to, so actually I didn't even need to do that because we're already out, like that one's out because we only have to go up to 9 over 18. So this one's in. So I'm going to minus, we better minus the periods. So I better minus 24 pi on 18 and minus 24 pi on 18 and see what I get. And I would get, say I would get negative 20 on pi on 18, and that doesn't fit in our domain. But the other one, I would get negative 4 pi on 18, and that one does. So this one, these two fit in. So the solution to these two is negative 4. So in the end, when I say cos 3x over 2 equals a half, when x equals, I'm going to say negative 4 pi on 18 and 4 pi on 18. Now they can simplify down to be negative 2 pi on 9 and 2 pi on 9. Okay, so that is your final answer. Okay, so these are just a quick evaluating when these are. So if you think of C10, 5 pi on 3, so you would be not quite, this would be 2 pi, which is 6 pi on 3. You'd be down here in this, you're just pi on 3 short of that. So the answer to 10 is equal to, now if we think about the cast, the C implies that only cosine is positive. So this is going to, means this answer is going to be equal to negative tan pi on 3. Okay, so we can therefore use our hand trick if we like. And the pi on 3 is this finger. So if this finger was down, tan is when you do the square root of the left over the square root of the right. So that would be, therefore, equaling square root 3 over square root 1, which equals 3, square root 3, because square root of 1. But because we have to make it negative, so it's negative. So my final answer is that. Okay, so if we think of cos negative 11 pi on 6, what you've actually done is gone round the other way. So you've gone around this way and you're not quite round to doing 2 pi. So you're in here and it's 11. So you're just pi on 6 short of making a full lap. So cos negative 11 pi on 6 is actually equal to the same as pi on 6. Okay, so I should write cos, the same as cos pi on 6. Cos pi on 6. So if I go back to my hand, I'll just redraw it again. Okay, so if I think about my hand, I want pi on 6. So pi on 6 is this one, the second finger, and cos is always the square root of those to the right, so it's square root 3 over 2. So we can say this one equals square root 3 over 2. Okay, alright, so with sine 4 over 3, where we would be down here, so sine is negative down there, so sine 4 pi on 3 is equal to the same as if we did sine pi on 3 but negative. Okay, so what we're going to do is do our hand trick, and we want sine pi on 3, which is this fingers down there, and remember that sine is the square root of the left fingers over 2. So it'll equal square root 3 over 2 but negative. Okay, and then the final one here, cos negative 2 pi. So you've got to remember when you go negative, we go around the other way, so we're actually in here. So cosine is negative there. So cos negative 2 pi on 3 is equal to negative cos pi on 3. Okay, so go back down, or if we think of our hand, remember cos pi on 3 is this finger, so it'd be the square root of the right over 2. The square root of 1 is 1. So cos negative 2h over 3 is equal to, it's a negative a half.